So in the previous session, we discussed how to identify the positive ions. Now this is a test for the negative ions, how we can identify the negative ions. If you want to identify the carbonate ion halide such as chlorine, bromine or iodine, nitrate, sulfate and sulfite. So these are the tests and respected observation will be there. If you want to test a carbonate ion, and this is all related to memorization, you have to learn these tests as well as the observations. So if you want to test a carbonate ion, react with acid, it will give carbon dioxide gas. So you will see bubbles will be there and the lime water will turn milky. If you want to test the halide ions such as chloride, bromide or iodide, so you would either add silver nitrate or you can also add lead nitrate. So if it's a white PPT means like when we mix two solution and a solid is formed, that is called precipitate. So if it is white PPT, it means chloride is there. Uh, if it is cream color precipitate, it will be bromide, and if it's a yellow PPT, then it will be iodide. Nitrate, we add aluminum powder and sodium hydroxide, it will turn red litmus blue, the gas get released. If sulfate is there, we'll add sodium hydrochloric acid followed by barium chloride, which will give a white PPT. And if sulfite is there, sulfate is SO4, sulfite is SO3. It will react with acid, it will give out sulfur dioxide, which will turn potassium manganate 7,2, purple to colorless. Potassium manganate is purple, but it will turn it to colorless. I'll show the video like related to this explanation. So if you want to test a carbonate ion, this is carbonate ion. So what we do, we add acid. If you want to test halide ion, halide means chloride, bromide, iodide. So what we do, we add nitric acid followed by silver nitrate. So if it give a white PPT, it means chloride is there. If it gives cream color precipitate, it means bromide is there, and if it is yellow precipitate, it will be iodide. This is what is added. So carbonate is tested by adding an acid. Halides are tested by adding acid followed by silver nitrate. If you want to test a nitrate ion, nitrate means NO3. Yes, any acid can be added. If it is written dilute acid, normally we add, any acid with carbonate gives carbon dioxide. So what we can do for nitrate, we can react with aluminum, zinc or copper and then add sodium hydroxide. So when we add sodium hydroxide, after adding aluminum, zinc or copper, what we'll observe? We'll observe when we heat it, we'll observe a pungent gas is released which turn red litmus blue. This is a test for nitrate ion. For sulfate ion, how we do the test? We add hydrochloric acid followed by barium chloride. So it will give a white PPT. And for sulfite, sulfite means SO3. What we do, we react with dilute acid. As a result, when it reacts with dilute acid, it gives off gas which will turn potassium manganate from purple to colorless. So now there's a video related to this. So in this video, we'll discuss how we can test the carbonate ion. If you want to test a carbonate ion, what we do, we add acid. Any acid can be added. If you want to add chloride, bromide or iodide, first we'll add acid. Normally nitric acid is added. So add nitric acid. HNO3 is nitric acid, and followed by what? Followed by either silver nitrate or lead nitrate. And we'll observe if it is white, then it will be chloride ion is there, white PPT. If it is a cream color precipitate, then it will be bromide. And if it is a yellow color precipitate, then it will be iodide. To test the nitrate ion, what we do, we add aluminum powder and add sodium hydroxide, NaOH, and we will heat. When we heat, there will be a pungent gas. That pungent gas is ammonia, and that pungent gas will turn the red litmus blue. To test the sulfate ion, we will add nitric acid followed by barium nitrate, or barium chloride can be added. So if it is a sulfate ion, will be the result? The result will be white PPT. For sulfite ion, we add hydrochloric acid HCl and we will heat. The gas will be released and which will turn the purple acidified potassium manganate to colorless. So in this video, you will see all the color changes and the observation related to these ions. So first example, if we want to test a carbonate ion. So how we can test a carbonate ion? Like this is a carbonate, like the salt is there, which contain carbonate. So what we did, we add nitric acid. Any acid it works. So when you add acid, what you are observing here, you can clearly see, you will observe bubbles. And these bubbles are due to carbon dioxide gas. So this carbon dioxide gas is released whenever carbonates are there, they are added or reacted with acid, so it will give carbon dioxide. And this carbon dioxide gas, we are passing through a lime water. This is a lime water. This lime water, which is calcium hydroxide, what happened to the lime water? The lime water will turn milky or chalky. So if the lime water turned milky due to the presence of, it confirmed the presence of carbon dioxide, and release of the carbon dioxide means that there was a carbonate ion. Is it clear? The previous one, the carbonate. Any question or a doubt till carbonate? Then if we want to test the halide ion, we don't know which halide. The term halide, what is the meaning of halide? It can be, even fluoride is there, but that's not part of your syllabus. That's why you don't have to learn. It can be chloride, it can be bromide or iodide. Any of these ions can be there. So if we want to test a halide ion, what we do, first we make a solution. This is a distilled water to make a solution, salt solution. We don't know which halide is there. So what we do, first we add nitric acid. As you can see, we are adding a nitric acid, and this nitric acid, using a dropper or a teat pipette, we add nitric acid, and this nitric acid followed by silver nitrate. So when we add silver nitrate solution to us, two solutions are there, but when we add this, you can clearly see a white PPT. So if there is a white PPT or a white precipitate, what it confirms an idea, this gives an idea that this salt is a chloride salt, because the chloride salts, like the halide ion, take position of a nitrate, so this gives white PPT. Then we are again making a salt solution. We don't know which halide is there, maybe chloride, bromide or iodide. So first, using a distilled water, we make a salt solution, then add nitric acid, and then followed by silver nitrate. So when we add silver nitrate, what you observe? You'll observe a cream color precipitate. So cream color precipitate means that bromide is there. This was white PPT. And then we add nitric acid followed by silver nitrate, and we'll observe a yellow PPT or yellow precipitate. So what it gives an idea, you can see here silver chloride is there. This one is cream color precipitate, silver bromide, and this one is yellow PPT. So it is silver iodide. This is iodide. Is it clear? The three observations for halide, testing the halide ions. Anyone having a doubt till this point? Doubt or a question? Then if we want to test the nitrate ion, so what we do, we have a salt solution. First, always this is done on a salt solution. So first we make a salt solution which contain a nitrate ion. So we'll add sodium hydroxide and aluminium. Aluminium foil can be added. Aluminium, you can see aluminium foil is added here. and then we will heat. So when we heat it, this mixture, as a result, what it gives, it will give a ammonia gas, and that ammonia gas is a pungent smell, irritating smell. So this pungent gas will turn the red litmus paper blue. So this is the aluminum foil you can see, and a salt solutions we add sodium hydroxide, and as a result it will give NH3 or ammonia gas. So as this ammonia gas is released, it will turn red litmus paper blue. And as the red litmus paper turned blue, it confirmed the presence of, this is a damp red litmus, it turned blue. So this confirmed the presence of ammonia gas. So this was a test for negative ion, nitrate ion. Then if we want to identify or test a sulfate ion, so for test for sulfate ion, we add a salt. So we make a salt solution first, and then we add nitric acid followed by barium nitrate, drops of barium nitrate or small amount. We'll observe a white PPT. So you can see here the white PPT. What is the white PPT shows? The white precipitate shows that it is a formation of barium sulfate. So this was about the test for sulfate ion. But sulfate, it the sulfite ion, it produces sulfur dioxide, which is a toxic. So it should be carried out in a properly ventilated room. These are the safety precautions. Or use a fume cupboard. These are the safety precautions related to identification of the sulfite ion. So if you want to identify sulfite ion, first we should make a solution. So we have a sulfite salt solution. Sulfite means SO3. We add hydrochloric acid and then we will heat it. Test for the sulfite ion, what we have, we add hydrochloric acid to a sulfite, and sulfur dioxide is a toxic gas, so it should be done in a properly ventilated room or a fume cupboard as a safety precaution. And what will happen, the gas which is sulfur dioxide, when we pass through a purple solution of potassium manganate, as you can see, we connect this, we place a bung here just to trap the gas, sulfur dioxide. And then when we pass, either we can pass or we can add potassium manganate. Like potassium manganate is added to a paper and then we place it above near the mouth of the test tube. So this purple color will disappear. You can see when you open, this purple color disappear. So purple color changes to colorless. This confirms that the gas which is released here was sulfur dioxide. And the ion which was present was sulfite ion. Sulfite ion means SO3. So these are the tests for the ions. The positive ions we have already discussed in the. So this is also you have to learn the test for the gases. If we have ammonia gas, it will turn red litmus blue. If it is a carbon dioxide, we add lime water, it will turn it milky. If it is a chlorine gas, we'll take a damp blue litmus, it will turn red and then bleaches. Like bleach means the color will be removed. If it's a hydrogen gas, then it will give a pop sound. Lighted splint is their pop sound. Oxygen gas, it will be a glowing splint and it will burst into a flame or glowing splint with relight. So as you can see here, different gases. So first one is ammonia, as shown here. Ammonia turned red litmus blue. A carbon dioxide, when we pass through a lime water, it turned milky. We already discussed, I have already shown you the effect of carbon dioxide on lime water. As we pass through a lime water, it turned milky or chalky. If it is a chlorine gas, so you can see first it turned red and then it bleaches. The term bleach means it turned into white. Hydrogen is there, like originally it's first chlorine turned blue litmus red and then it bleaches. If hydrogen is there, it will give a pop sound. And the last one, if oxygen is there, we add to a mixture of the glowing splint, what we observe, it will relight or it will burst into flame. So you have to learn the tests for these gases as well. Now there's also a video recording related to the test for the gases. I will show in a minute. So to identify the gases, we can use these tests and use these observations to identify the gas given off. But in this video, they also show that how the gas is produced. But you don't have to learn how gas is produced. The important thing is you should learn how we can identify that gas. Example, the first one, if you want to identify oxygen gas, so here you can see we want to identify oxygen gas. This is a glowing splint. You don't see a flame here on a glowing splint. And to test the oxygen gas, what we did, as we place in a gas jar which is completely filled with oxygen, so you can see the glowing splint, it relight or it bursts into flame because oxygen support burning, oxygen help in burning. That's why this glowing splint will relight. So again, like we have a glowing splint when we place in a gas jar which is completely filled with oxygen, as the oxygen support burning, so we will see the flames. The second one, you don't have to learn production. Like here in the video, they're also showing how it is produced, but you don't have to learn production. You have to learn how it can be tested. Like if hydrogen gas is there and we bring a lighted splint, so the sound, you cannot hear the pop sound, but it produces like when a popcorn produces specific sound when a corn turns into popcorn. So the same idea is there, same type of sound is produced. That's why we call that when the hydrogen gas with a lighted splint, it will produce a pop sound. So this is a second test, the test for the hydrogen gas. So with hydrogen, when there's a lighted splint, as a result, it will give a pop sound. If you want to test a carbon dioxide, so first a carbon dioxide gas is produced, and this carbon dioxide gas which is produced is passing through a lime water. This is a lime water. Originally the lime water is crystal clear, but when we bubble the carbon dioxide, the lime water will turn milky. So if the lime water turned milky or chalky, it means the gas which is released here or the gas which is given off is a carbon dioxide gas. So the lime water will turn milky. First, we are producing chlorine gas here. This is how chlorine gas is produced by using electrolysis. Now this chlorine gas, what is the test? Again, you don't have to learn how it is produced. You have to learn the observation that how this chlorine gas is produced. So this chlorine gas is produced by electrolysis, and then what we do, we test with a damp blue litmus. When we are testing with a damp blue litmus, first the litmus paper will turn red and then it bleaches. Like as you can see, first it turned into red, and with the passage of the time this litmus paper will bleach. So when it is bleached, it means like first it was like blue, then it turned red, and then bleach means the color is removed. So this confirms the presence of chlorine gas. Is it clear, this part? The test for the gases. So these are the tests which you have to learn for ammonia, damp red litmus, damp blue litmus, the damp red litmus, it turned blue, carbon dioxide, lime water turned milky, chlorine, blue litmus, bleach, turned red and then bleach, hydrogen, lighted splint, pop sound, oxygen, glowing split, relight, sulfur dioxide, potassium, manganate, it will turn into colorless. Purple will change to colorless. So this was topic 8.4, which is about the identification of ions, and it is a very important topic. The paper 6 totally based on the identification of the ions. Any question or a doubt related to the session?